Transpiration Lab by
Vanessa Briseño
and Bonnie Lynn. The research question of this lab is, does the wind speed affect the rate of transpiration of a plant as measured with a potometer? The independent variable of this lab is wind speed, while the dependent variable is rate of transpiration. The controlled variables include temperature, which will be measured in each trial, light, humidity, time, plant species, tubing for potometer, distance from fan, and pipette. Procedures. First, obtain a 5 ml volumetric pipette, plastic tubing, a syringe, a plastic bin, a ring stand, metal clamp, parafilm, scissors, a fan, and a small branch with leaves. Step 2. Fill plastic bin with water, attach the tubing to the pipette, and use parafilm to seal if necessary. Note: make sure the tubing and pipette attachment is airtight. Step 3. Submerge the pipette under water and use a syringe to absorb water through the plastic tubing. Water should fill the pipette and no bubbles should be present within the tubing or pipette. Step 4. Place the branch under water and while submerged, cut the tip with scissors. Insert the branch into the tubing while it is still submerged in water. Use parafilm to create a seal. Step 5. Using a ring stand and metal clamp, place pipette and tubing on either side to create a potometer. Step 6. Perform a control. Record the volume of water in the pipette prior to allowing transpiration to occur, then set timer for 5 minutes. Observe the volume of water after 5 minutes. Perform 3 trials. Step 7. Set up fan in front of the plant. Ensure that the distance between the fan and the plant is maintained constant throughout the lab. Step 8. Set the fan on low wind power setting and observe the volume of water prior to allowing transpiration to occur. Observe the volume of water in the pipette after 5 minutes have passed. Perform 3 trials. Step 9. Repeat Step 8 for medium and high wind power setting. Step 10. Once all trials are complete, determine the surface area of leaves and the plant. Step 11. Calculate the rate of transpiration.
Results. As seen in Table 1, a control was performed in which a fan was not used to blow wind onto the leaves of the plant. After 5 minutes, the volume of water in the pipette did not change. This is visible in all 3 trials. Table 2 shows the results for the high-power wind speed setting trials. In both Trial 1 and Trial 3, the total amount of volume lost was 0.04 mils. However, in Trial 2, the amount of water transpired was 0.01 mils of water. In Table 3, the medium-power wind speed setting is displayed. In Trial 1, the total volume of water that transpired was 0.02 mils. Trial 2 shows that 0.01 mils of water were lost. Finally, 0.01 mils of water were lost in Trial 3. Table 4 displays the results for the low-power wind speed trials. In all 3 trials, the volume of water decreased to a total of 0.01 mils. Table 5 shows the calculated rate of transpiration in mils per centimeter squared per minute. The average rate for the controlled trials was 0. Table 6 shows that the average rate of transpiration for the high-power wind speed setting was 0.000071 mils per centimeter per minute. Table 7 shows that the average rate of transpiration was 0.000032. Table 8 shows that the rate of transpiration for the low-power wind speed was 0.000024 mils per centimeter squared per minute. Figure 1 is a bar graph displaying the average rate of transpiration for each wind speed. As can be seen, the highest rate of transpiration is that of the high-power wind setting. The lowest rate of transpiration is the low-power wind speed trial. Finally, the medium-power wind settings have a rate of transpiration that is in between that of the high speed and the low speed